Imagine standing under a night sky, so bright you can see the Milky Way spilling across the darkness, like a river of light. No city glow, no satellites, just stars, thousands of them, burning quietly above ancient lands. Now imagine a civilization, thousands of years ago, mapping those stars with a level of accuracy that still shocks modern astronomers. Not guessing, not myths, real measurements, real alignments, real records carved into stone and written into time. Sounds unreal, right? Follow Mystery of the Ancients right now and don't blink, because what you're about to hear will change how you see the ancient world forever. Long before telescopes, computers, or even glass lenses, ancient observers were already tracking the movement of the heavens with obsessive precision. They noticed patterns in the rising and setting of stars. They recorded how certain constellations appeared at the same time each year. They tracked the slow drift of the night sky over generations, something we now call precession. These people didn't just look up at the stars for beauty. They studied them like scientists. And one civilization in particular left behind evidence that their star maps weren't symbolic. They were accurate, uncomfortably accurate. In ancient Egypt, the sky wasn't just a backdrop. It was a blueprint. The placement of monuments reflected the heavens. The builders believed the soul of the king would ascend to the stars, and they aligned sacred architecture with specific constellations. Some researchers argue that the layout of the pyramids reflects the pattern of Orion's belt, frozen into stone on Earth. Whether you accept every detail of that theory or not, what can't be ignored is the precision of Egyptian astronomical knowledge. Their temples were aligned to solstices and stellar risings. Their calendar was synced with the heliacal rising of Sirius, which predicted the flooding of the Nile with astonishing reliability. This wasn't coincidence. This was data collected over centuries, passed down carefully through priest astronomers who treated the sky like a sacred code book. But Egypt wasn't alone. Across the Atlantic, the Maya developed one of the most complex astronomical systems in human history. Without metal tools, without telescopes, and without written numbers like ours, they calculated planetary cycles with precision that rivals early modern Europe. Their records of Venus cycles were so accurate that modern astronomers still compare them to contemporary calculations, and the margins of error are shockingly small. The Maya didn't just track the sun and moon. They tracked planets. They predicted eclipses. They encoded cosmic time into their architecture. Entire cities were oriented around celestial events, turning stone into a working observatory. Think about what that means. To measure planetary cycles, you need long-term records. Decades, centuries, generations of observers passing down exact data without corruption. One mistake and the system falls apart. Yet it didn't fall apart. It worked. That alone tells us these civilizations valued accuracy over mythology. The sky wasn't just a story, it was a schedule. Then there's Mesopotamia, where Babylonian astronomers created some of the earliest known star catalogs. They recorded the movements of planets using mathematical patterns that laid the groundwork for later Greek astronomy. They didn't just say, Mars appears here sometimes. They tracked when Mars would appear, disappear, retrograde, and return. They predicted celestial events with rules that modern historians now recognize as early forms of scientific modeling. These weren't priests staring at the sky for signs from gods. These were early scientists building predictive systems. What's unsettling is how little credit ancient civilizations get for this. We like to imagine that advanced astronomy began with telescopes in Renaissance Europe. But the truth is, the groundwork was laid thousands of years earlier by people who had nothing but patience, memory, and stone. No computers to correct errors. No digital records. Just human observation sharpened across generations. And here's where it gets even stranger. Some ancient star maps appear to reflect the sky, as it was thousands of years before they were carved. Because of Earth's slow wobble, the positions of stars shift over long periods of time. This means that if a carving matches a specific ancient sky configuration, it may be pointing to a date far older than the civilization that left it behind. That raises a haunting question. Were these people preserving knowledge from even earlier observers? Were they inheriting star maps from lost cultures we no longer remember? Look at ancient stone sites aligned with star risings that no longer happen in the same way today. The alignments are real, but the sky has moved. That means the builders were encoding a snapshot of the heavens at a specific moment in deep time. Not myth, not symbolism. A record, frozen astronomy. So why were they so obsessed with the stars? Part of the answer is survival. The sky was a calendar. It told them when to plant, when to harvest, when floods would come, when seasons would change. But it was also spiritual. The stars represented gods, ancestors, and the afterlife. Mapping the sky wasn't just science. It was a way of anchoring humanity inside the universe. A reminder that life on Earth was part of something vast and ordered. Here's the uncomfortable part for modern minds. We often assume ancient people were primitive. But when you look at their star maps, alignments, and predictive systems, that story falls apart. These civilizations didn't stumble into astronomy. They mastered it through discipline, patience, and generational knowledge transfer. In some cases, their long-term observations rival the accuracy of early modern astronomers who had metal instruments and written mathematics. So what happened to this knowledge? Why did it fade? Wars, collapses, invasions, climate shifts, and the loss of priestly classes who preserved data all played a role. When a civilization fell, its star maps didn't get backed up to the cloud. They vanished. Libraries burned. Observatories crumbled. The chain of memory snapped. And yet, fragments remain, carved into stone, written on surviving tablets, aligned into monuments that still catch the sun and stars at precise moments every year. These are not accidents. They are messages from ancient scientists who never knew we would exist, but whose work still speaks to us across millennia. If they could map the stars with impossible accuracy using nothing but naked eyes and patience, what else do they know that we've forgotten? And how much ancient knowledge is still hiding in plain sight, waiting for us to relearn how to read the sky? Now, picture this. Two monuments on opposite sides of the planet, built by cultures that never met, both pointing the sky with the same obsession for precision. That's not coincidence. That's a global pattern. Follow Mystery of the Ancients and stay with me, because this part exposes how deep the star mapping really went. Let's start with the architecture that turned stone into astronomy. In ancient Egypt, sacred structures weren't placed randomly. Many scholars argue the layout around Great Pyramid of Giza mirrors patterns in Orion's belt, a constellation linked to the afterlife and divine kingship. Even if you're skeptical of perfect one-to-one matches, the undeniable truth is this. Egyptian builders aligned temples and corridors to stellar risings with precision that required decades of careful observation. They weren't eyeballing the sky once a year. They were tracking it across generations, refining angles until the alignments locked into place. That level of precision doesn't come from belief alone. It comes from measurement. Now cross the ocean to Mesoamerica. The Maya didn't just admire the stars. They built cities around them. At Chichen Itza, structures were positioned to interact with sunlight and celestial cycles in ways that still function today. Their records of Venus cycles were so accurate that modern astronomers compare them to contemporary calculations, and the differences are tiny. Think about that. A civilization with no metal tools and no telescopes calculated planetary periods with errors so small they still impress scientists. That requires disciplined record-keeping over centuries. One generation observes, the next corrects, the next refines. This is how science is born, long before we decided to call it science. And then there's Mesopotamia, where ancient astronomers in cities like Babylon created star catalogs that track planetary motions with predictive rules. They recorded when planets would appear, vanish, and return. They noticed retrograde motion. They built early mathematical models to forecast celestial events. This wasn't astrology in the modern, vague sense. This was proto-astronomy, pattern recognition turned into prediction. They weren't guessing the future. They were calculating it from the past. Here's where the story turns unsettling. Some star alignments preserved in stone appear to match the sky, as it looked thousands of years earlier than the monuments themselves. Because Earth slowly wobbles on its axis, the positions of stars change over long time spans. This means certain alignments act like timestamps. If the stones point to sky configuration that only existed in deep antiquity, then one of two things must be true. Either the builders preserved ancient knowledge from much older observers, or they inherited star maps from a culture we no longer remember. Either way, It hints at a chain of astronomical knowledge stretching further back than our history books comfortably admit. Think about how fragile knowledge is. One war, one fire, one invasion. Libraries vanish. Priestly classes are wiped out. Observatories fall silent. When that happens, precision knowledge collapses into myth. Stories remain, but the math disappears. That's likely why we see fragments of advanced astronomy scattered across the ancient world instead of one continuous scientific tradition. Each civilization inherited pieces of the sky map puzzle, used it for survival and ritual, then lost parts of it when they fell. And survival is the key word here. The stars weren't just beautiful. They were practical. Stellar risings marked planting seasons. Planetary cycles timed rituals and political events. Solstices told farmers when to prepare fields. The sky was a clock, a calendar, and a navigation system all at once. If you misread it, crops failed. If you tracked it well, civilizations thrived. Accuracy wasn't optional. It was the difference between stability and collapse. What's wild is how patient this science was. Modern science thrives on fast data. Ancient astronomy thrived on slow truth. Observers watched the same stars night after night, year after year, lifetime after lifetime. They noticed tiny shifts most people would never catch. Over centuries, those tiny shifts formed reliable patterns. This is why their calendars and planetary tables worked. They were built on long memory. So when people say ancient civilizations were primitive, they're really revealing a blind spot. These cultures didn't lack intelligence. They lacked machines. But intelligence plus patience can still produce precision. In some ways, their methods were purer. No software glitches. No algorithmic bias. Just human eyes, careful notes, and relentless consistency. And that raises a haunting question for us today. If ancient people could map the heavens with naked eyes and memory, what else could they measure that we've forgotten how to see? What patterns in nature are we missing? Because we no longer watch anything for long enough. The ancients didn't just look up at the stars. They listened to the sky over generations. And the sky answered them with patterns they turned into stone. What if the greatest observatories in human history weren't built with glass lenses, but with stone, shadow, and silence? And what if the people who built them understood cosmic cycles so deeply that we are only now rediscovering what they already knew? Stay with mystery of the ancients, because this is where the mystery becomes undeniable. By now, one thing is clear. Ancient civilizations were not randomly staring at the sky. They were conducting long-term sky surveillance. But here's what makes it extraordinary. Some of their measurements required tracking movements, so subtle they unfold across centuries. Take Earth's axial precession. This is a slow wobble of our planet that shifts the position of stars over thousands of years. Today, we measure it with advanced instruments, but some ancient alignments suggest that early astronomers were aware of these gradual shifts. They may not have used modern terminology, but their architectural corrections hint that they noticed the sky wasn't perfectly fixed. That level of awareness requires multi-generational data comparison. One generation marks a star rising at a certain point on the horizon. The next generation notices it rising slightly off that point. The next generation adjusts their alignment. Over centuries, tiny changes become undeniable. This is slow science, deep time science. At sites like Nabta Playa, some of the world's oldest known astronomical alignments appear to mark stellar positions and solstices dating back thousands of years. Massive stones arranged in patterns that correlate with celestial events. This wasn't accidental geometry. It was observational memory turned into architecture. And then there's something even more fascinating: encoded cycles. The Maya didn't just track Venus casually. They calculated its synodic cycle with astonishing precision. Venus disappears and reappears in predictable intervals. And the Maya recorded these patterns so accurately that modern scholars have compared their tables to NASA data, and the margins are incredibly small. That means they tracked Venus across centuries without losing numerical consistency. Think about the discipline required for that. No printing press, no spreadsheets, no digital backup, just carved records, bark paper codices, and relentless observation. And they weren't alone. Ancient Mesopotamian astronomers created predictive schemes for lunar eclipses. They noticed repeating cycles, what we now call the Saros cycle. By recognizing that eclipses repeat in patterns roughly every 18 years, they could forecast future eclipses based on past records. That is advanced pattern recognition. That is structured astronomy. The deeper you go, the more uncomfortable the narrative becomes. Because the traditional story says advanced science begins in classical Greece, accelerates in Renaissance Europe, and explodes in the modern age. But the evidence scattered across Egypt, Mesoamerica, and Mesopotamia tells a different story. It suggests that the roots of predictive astronomy stretch far deeper into antiquity than most people realize. Now imagine something else. What if knowledge wasn't invented once, but rediscovered repeatedly? Civilizations rise. They study the sky. They map it. They refine it. Then collapse happens. Knowledge fragments. Survivors pass down myths instead of measurements. Centuries later, another civilization looks up and starts again. Could advanced star mapping have emerged multiple times in human history? Because here's the truth. Mapping planetary cycles, tracking stellar drift, and predicting eclipses does not require modern technology. It requires patience, consistency, and generational continuity. If a culture maintains stability for long enough, precision astronomy becomes inevitable. The sky is predictable. Humans are curious. Combine the two over centuries, and science appears. But here's what makes it powerful. Many ancient alignments still work today. On specific dates, sunlight still pierces ancient chambers. On certain nights, stars still rise over stone markers exactly as designed. The sky has shifted slowly, but not enough to erase their accuracy. These monuments are not ruins. They are still functioning instruments. And that changes everything, because it means ancient astronomers were not myth makers guessing at the heavens. They were system builders, data collectors, long-term observers of cosmic rhythm. We often ask, how did they do it? But maybe the better question is, why did we forget how powerful patient observation can be? The ancients didn't rush discovery. They earned it over lifetimes. They treated the sky as a sacred archive, and in doing so, they left behind something extraordinary, a reminder that human intelligence has always been capable of greatness, even without machines. And we are only now starting to respect that truth. What if the greatest discovery about ancient astronomy isn't how accurate it was, but how easily it can disappear? Stay with Mystery of the Ancients, because this final part reveals why lost knowledge may be humanity's biggest repeating mistake. When we look at ancient sky mapping today, we're not just seeing clever alignments or beautiful monuments. We're seeing the remains of long scientific traditions that were violently interrupted. Civilizations don't usually fade quietly. They collapse through droughts, invasions, internal conflict, or sudden climate shifts. When that happens, knowledge systems collapse with them. The astronomers die. The students scatter. The records burn. The observatories fall silent. What survives are fragments, stone alignments without manuals, carvings without instructions, myths without measurements. In ancient Egypt, the knowledge of the sky was preserved by priestly classes who passed precise observations across generations. But when political systems changed, that continuity broke. Temples were abandoned. Rituals survived, but the original astronomical logic behind them faded into symbolism. The sky maps turned into stories. In Mesoamerica, the Maya maintained advanced astronomical records for centuries. But warfare, environmental stress, and societal collapse fractured that system. Codices were destroyed. Observatories were abandoned. What had once been precise planetary tables became legends about gods and cycles. The science was still there, hidden, but the method of maintaining it was gone. And in Mesopotamia, where some of the earliest predictive astronomical models were created, invasions and empire shifts scattered scholars and erased institutions that once preserved sky records. The knowledge didn't vanish instantly. It decayed. Precision slowly turned into tradition. Tradition slowly turned into myth. This is how advanced knowledge dies. Not because it was wrong, but because the systems that protected it failed. Here's the uncomfortable truth. Human intelligence doesn't automatically move forward in a straight line. It advances in fragile bursts. When stability exists long enough, civilizations map the heavens, measure cycles, and decode patterns in nature. When stability collapses, knowledge doesn't survive on its own. It must be actively protected. If it isn't, it resets. This is why ancient star mapping feels shocking to us. Not because humans suddenly became smart thousands of years ago, but because we forget how easily intelligence can be erased by chaos. Now think about our world. We store knowledge digitally, in fragile servers, in formats that may not survive centuries. If modern civilization collapsed tomorrow, how much of our science would survive in usable form? Would future humans understand our records? Or would they find fragments, satellite debris, ruined observatories, broken data centers, and wonder how we knew so much and lost it? Ancient monuments still align with the sky, because stone survives when libraries burn. The stars outlive empires. And these structures stand as quiet proof that ancient people didn't just worship the heavens. They studied them with discipline, patience, and precision. So the real mystery isn't how ancient civilizations mapped the stars so accurately. The real mystery is why we ever assumed they couldn't. What if the stars remember us? Even when we forget ourselves, stay with mystery of the ancients, because this final moment ties the ancient sky to our future. For thousands of years, the night sky has remained mostly unchanged to the human eye. Empires rose and fell beneath it. Languages were born and died. Cities turned to dust. Yet the stars kept moving in their slow, predictable rhythms. Ancient civilizations learned to read those rhythms like a cosmic clock. They turned patterns of light into calendars, monuments into observatories, and memory into stone. When you stand beneath an ancient monument aligned to the heavens, you're standing inside a message sent across time. A message that says, "We were here. We were watching. We understood more than you think." These builders didn't leave us instructions in modern language. They left us alignments, angles, and cycles. Their knowledge wasn't meant to impress the future. It was meant to help them survive their present. The fact that it still speaks to us today is almost accidental and deeply humbling. Modern science often feels separate from ancient wisdom, but in truth, they are part of the same story. The ancients began the long conversation with the cosmos. We are continuing it with new tools. Telescopes extend our vision. Computers extend our memory. But curiosity, the engine behind it all, has not changed. The same curiosity that made ancient observers sit in the dark for generations, tracking the slow drift of stars, still drives us to explore distant galaxies today. So the next time you look up at the night sky, remember this. You are sharing that view with people who lived thousands of years before you. They mapped those stars with nothing but patience and wonder, and their work survived long enough to remind us that human potential has always been vast. Our memory of it is what's fragile. Follow Mystery of the Ancients for more hidden truths written in stone and starlight, and comment, "Starborn," if this journey through ancient astronomy changed the way you see the sky.